Good afternoon, everyone, and welcome to today's webinar on IoT applications leading the future of wastewater treatment solutions. Today we have Christopher Dooley, CEO of DMP Corporation, to walk us through this evolving topic. Prior to his time at DMP, Chris held senior leadership positions in other fast-growing organizations, including the Alexander Group, a sales and marketing strategy consultancy, and Siebel Systems, the leading provider of CRM software acquired by Oracle. Given his experience in technology, marketing, and sales, Chris has led DMP to bridge the gap between automation and wastewater treatment. My name is Dolores Alonzo, and I'm VP of Membership here at FPSA. This webinar is being recorded, so you and any of your colleagues will have access to it in the members only section of the FPSA website after today. The slides are included as an attachment for your reference. So before I pass this over to Chris, I want to cover just a few housekeeping items. All attendees are muted by default, but you'll have the opportunity to submit text questions to Chris today by typing them in the questions pane of the control panel. You can also send them in at any time during the presentation. Or, of course, Chris will be providing his contact information, and you can contact him after the webinar as well. So let's get started. Chris, I'm going to pass this over to you. It'll take a second or two.
Terrific.
Okay.
All right. Did that work?
Yes.
All right, great. Well, hey, thank you, Dolores. Appreciate it, and I thank you to you and the and FPSA for giving us the opportunity to talk about this topic with our fellow members. This, as you mentioned, my background in IT and in water, this is something that's a particular interest to me. So I love the opportunity to be able to really share my thoughts on it, but more importantly, have a discussion with other folks and see where they see that this is being used today or where it could be used more effectively. So with that, I'm gonna jump in. Not to spend a lot of time talking about DMP, but I do want to give a little bit of a background on who we are, just because I think it gives you a little context to the things I'm about to talk to and give you a better understanding of where it is we're coming from as a company when we draw these conclusions. So DMP, we've been around for about 45 years, and we really focus on wastewater. You can see our mission there is taking the worry out of wastewater. So really everything we do from a product development and a service development and interacting with our customers is designed around making it as easy as possible to treat your wastewater, with the understanding that our customers do not make money on treating their wastewater, and what our job to do is allow them to free up more brain power and manpower and money to go focus on building their products and services for their customers. So real quickly, the way we do that is through what we call an integrated and holistic approach. That means we design, build, and install full treatment systems, as well as on the back end, after having them installed and doing startup and training, we provide the chemicals, the service, and a performance guarantee to our customers to ensure that they're successful in operating the equipment that we've designed for the long term. So that's really our approach. It's about 100% accountability. And again, not a commercial, just to give you a sense for what our business is. So with that, let me jump into the main presentation. What am I hoping to accomplish today? One is demystify this whole industrial Internet of Things. One thing the technology industry is really good at is galvanizing interest through the creation of new buzzwords and concepts, even when it's just small incremental innovation we're talking about. And sometimes it takes a while for everybody to kind of re-get their head around, okay, what does everyone really mean by that? I know I hear a lot in the press that this is super important and I ought to focus on it, but at the heart of it, what does it really mean? And so what I'm hoping to do is kind of just start off by creating a common definition of what we're talking about when we say industrial Internet of Things. Secondly, just to understand where is it today, in particular with respect to wastewater treatment. What are people doing today? What may we and some of our customers be able to do with it right now? Secondly, what will it open up in the future that people aren't doing today, and how's that going to impact food processors and their wastewater treatment efforts? And then, of course, lastly, for food processors, when they're thinking about, hey, regardless of where you are in the adoption of some of these technologies, what do I need to start thinking about today if I want to take advantage of some of these innovations in the coming future? So that's kind of what I hope to accomplish in walking through the next few slides. All right, so with the purpose of creating a common definition, look, Internet of Things as we understand it in our lives as consumer isn't really all that complex, right? It's just taking an individual piece of equipment, having capture data, and then share that data via the internet with either other machines or with a user, hopefully to enable decision making, right? The simplest example, which I'm sure everybody's aware of, is the Nest thermostat, right? For those of us like me who live in Chicago, and when I escape to warmer climes sometime in January, I'll turn my thermostat down to 55 degrees to just, that sweet spot where my pipes don't freeze, but I'm saving some energy. But I want to have that turned up so that when I show up on Sunday night from the plane, that it's nice and it's a nice warm 70 degrees when I get there. The Ring doorbell, I'm sure everyone's familiar with as well. So again, same idea. I get to interact with people on my doorstep from a remote location for better security purposes. And now they're smart refrigerators, smart stoves, you name it. They're giving us the ability to interact with our equipment over the internet. So extending that to the industrial world, it gets a little bit more confusing, not because the basic concept is any different. It's really still about taking discrete pieces of equipment, gathering information and collecting that information or sharing it through the internet. I think where it gets a little bit more confusing is it gets bundled up with a bunch of other buzzwords that are out there that we hear a lot about. Industry 4.0, the smart factory, artificial intelligence, big data, machine learning. I'm kind of really just even scratching the surface. The reason why they get bundled up is because the Internet of Things really is just connecting those pieces to the internet. And getting that data in somewhere off-site. But it's really the important part from an industrial perspective is what do you do with that data? As more and more pieces of machinery and equipment become connected to the internet and create this Internet of Things ecosystem, you're able to collect more and more data, and it gets more and more confusing with, well, how is this important or helpful to me in achieving my business goals? And that's really where some of these other technologies start to become important and saying, now that we've got it, what do we do with it, right? Big data is all about analyzing it. Artificial intelligence is using that data to, it's really similar to machine learning. They're almost sort of the same thing, where you're able to enable the machines to do the analysis, but more importantly, take decisions on the analysis of that information in real time without operator involvement. Industry 4.0 or the smart factory just is the utilization of all of these different technologies in different formats to make a better running operation. What's driving it? Why are we talking about this now? Not all of these concepts in terms of automation or analysis to drive better analysis, driving better operating decisions is really all that new. And really it comes down to a couple of things. One, it's become a lot easier and cheaper to get good information, which enables all of this. And that's really sensors are getting cheaper, which is always helpful in implementation. They're also getting better. The information is more reliable, and they're getting better at being self-maintained, particularly in wastewater treatment, right? Where if you implement a sensor, but you've got to send somebody out there every 20 minutes to clean it off to make sure you're getting good readings, it's not really that helpful. So those sensors are getting it better at just taking more accurate readings, lower maintenance requirements, and getting cheaper and smaller so that they're a lot easier to implement inside of your wastewater treatment system. The second piece is not only is it easier and cheaper to get good information, it's also easier and cheaper to communicate that information. So wireless chips, again, collecting it with the sensors is great, but if you can't get it to the internet in some way, that's not so helpful. So the wireless chip advancements, and that's really, again, about cost and footprint, making them small enough so that you can embed them inside of, a flow meter or a valve or what have you, it makes it much more practical. If you have to double the size of your flow meter to connect it to the internet, it really lessens its utility. So the fact that they keep getting cheaper and smaller has made it a lot easier to connect discrete pieces of equipment to the internet. And then lastly is, as well, and that top bullet point though, high-speed internet access, right? And the smartphones and tablets is the last piece of the puzzle, is that's making it easier to access that information. So once you gather it and once you send it out to the cloud, what are you going to do with it? And so, the penetration of smartphones and tablets, as well as how much cheaper it's gotten to connect those things to the internet wirelessly, has made that information suddenly much more useful because people can interact with it at the point where they need to make decisions. They don't need to be standing behind a control panel in a room or up on the catwalk at the control panel itself. So, again, coming back to that age-old question of, why do we even care? Well, on the industrial side, there tends to be three main reasons why people in industry are concerned about Internet of Things. The first one, really not so important to the conversation today, but still worth mentioning, is it's about responding to changing customer requirements quickly. If you take an example of a GE locomotive, not food related at all, but it'll drive the point home, which is they now have over 200 sensors embedded in their locomotives that take real-time operating data from every new one of those they sell and agglomerate it. Why do they do that? Because it's the best customer focus group that they're ever going to get. They don't have to ask people how they use it or what they struggle with or what works and what doesn't. They're real-time able to monitor it and figure out, what are the different pieces of functionality? How are people actually running our locomotives? How is that stressing the way it was designed? And allows them to make much better decisions on planning future product releases and innovations. I'll go to the last one as well because we're not going to go into that as much, but this one has some impact on wastewater treatment, but we're not going to spend a ton of time talking about that today. What it also allows you to do is to design better products and services. Really, it's more on the services side, all right? Now, if I have more sensors in a customer's wastewater treatment systems, it's going to allow me to develop new types of services like remote monitoring, and that's just the most simple and obvious example that I can provide back to my customers that would be absolutely impossible if I weren't able to collect and utilize that information. So now, where's the real benefit? And where we are today in the industrial Internet of Things is it's really focused on that middle bullet point there in red, optimizing available resources and processes. And, really when it comes to wastewater treatment, what we're talking about there is how do I decrease labor, right? How do I better automate these things? How do I save money by making better operating decisions and reducing my chemical usage and my power usage? And lastly, how do I get better results, right? How do I lower my surcharges, my fines by better operating my wastewater treatment plant? Now, in order to do that, right, again, this comes back to this will be the common theme that we talk about here. At its heart, Internet of Things is about collecting more data, but then applying analytics to it, right? Call it big data, business intelligence, whatever you want to do, but it's analyzing not just the data, getting the right data, analyzing that data, and then using that data to automate processes to reduce labor and create better outcomes, extending the life of assets through better preventive maintenance and things of that nature in order to, again, save money, drive better results at the bottom line for your company. So it's all really fundamentally about data and analyzing that data. Again, I think I sort of hinted at this at the beginning, All right, hey, we've got some pretty good, SCADA-based systems out there that do a lot of this automation that I'm talking about. So how is IoT distinctly really different than what we're doing today? Well, it's not really that different, frankly. It's sort of, to call it the evolution of what we're doing today with the SCADA systems, right? You can see from this diagram, right? Think of it as it's one SCADA, just your SCADA system is one source of information. What the Internet of Things platform inside of a company can actually do is it allows you to combine that information from that one system with information from other systems to provide a much richer sense of how your operations are going and allow you to make better, more impactful decisions. So on the SCADA side, right, you've got your PCs, you've got your remote terminal units, you communicate through Modbus and TCP, sometimes wirelessly, and then you use that to supervise and automate, right? Doesn't sound hugely different than what I was just mentioning IoT allows you to do. The real difference is, again, this ability to combine that information in a cloud-based data repository. Now, the reason why the whole cloud-based is important is it's the fundamental ease with which you can now add important new information into the database to allow you to make better decisions. Imagine how long it would take if you were to just do an add-on to your wastewater treatment system, right? How much easier is it to discreetly use a sensor inside of that new piece of equipment to send new data to a cloud repository where you're going to then analyze that data and make better operations decisions, then to have that whole thing reprogrammed back into your SCADA system. It's just that much easier to actually make this whole thing work. Or again, taking information from somewhere else, or another discrete system with its own SCADA system, right? That just becomes much easier if everything goes to a common data platform that's in the cloud. But again, if you going back to it, it's the analytics though and the mobility that really add the power here. The analytics is obvious, right? What does the data mean? If I don't know what it means, I'm not going to be able to do much with it. The mobility piece, though, again, comes back to now that it's in the cloud, it's a lot easier to give it back to the people who need it, meaning the operators typically, when they need it, where they need it. So giving it to somebody when they're out if you pulled them off the wastewater treatment line and they're doing something on the production side, but something comes up they need to attend to, giving them the ability to not only have a look and understand what's actually happening on their phone or on an iPad or a tablet, and then also be able to interact back with that system and control it and make decisions and hopefully not have to leave wherever it is they are. And that's really, like I said, just it's an extension and an improvement upon what we're able to do today. So we'll start with the first case study to kind of drive home what are some interesting stuff and some real live results. I wish I could say that DMP was involved with this one, but we weren't. But I still think this is a wonderful example of what's possible. Now, this is actually going to be a municipal, not a food example, but it shares some things in common. And because it's fundamentally it's solid separations and biological treatment, and it's just a really good case study with some really hard data on it to show what's possible. So this was done in Spain with a company named Aqualia, and one of the larger municipalities inside of Spain. So to set the stage, I did what a lot of municipal plants do, right? At the beginning of each season, they would set the settings and they would fix them for the season in terms of how the plant was going to be run. And then any modifications they would make from there on out were based on their operators' experience and intuition. When they, if temperatures get unusually hot, unusually cold, the load coming in is a little bit stronger, they would make adjustments to the system based on what they've seen work from their many years of experience. Like all operations, right? Water volumes and strength, frankly, varied throughout the day, causing you to have to try and adjust in real time. If you could, often if you don't, you just kind of set the settings and you leave them because you don't have the ability to adapt to them and you don't have the ability to see those changes far enough in advance. And of course, as we're all aware of, bacteria efficacy was highly dependent on the temperature of the water. So from a solution perspective, the first thing they did, they took a phased approach here. The first thing they did was went and put the sensors out there, right? Every sensor you can imagine that they went out and put out there, pH, temperature, DO, et cetera, on the influent, on the effluent, at different places inside of the system, because they weren't necessarily 100% certain, though they had suspicions on which data was going to be important for making which decisions. That was the hard lifting after they collected it. So they collected a year's worth of data, and then they went and they did the heavy lifting of analyzing that data to figure out which ones were which pieces and levers were statistically significant, and how did it all work together. Based on the analysis of that data, they created predictive models, right? In situations X, Y, and Z, you would do A, B, and C to improve your outcomes. And then they didn't go to full automation. What they did was they used those predictive models, again, collecting all this information on these sensors that they added into an existing system, collected the data in the cloud, analyzed it. Now, as the data continues to come in, based on what that looks like and running it through these models, every 2 hours, they make recommendations to the operators. Then the operators are then able to tweak the system and while the predictive model gives them suggestions, again, using that experience into an intuition, which you never want to throw out, they could either listen to it or tweak them. As a result, and then this is, the proof's always in the pudding, they were almost a 14% reduction in electricity consumption, 14% reduction in chemical usage, 17% reduction in sludge generation, better nitrogen removal, right? I mean, that's fantastic. And that last bullet point there really was a great one, which is, hey, if you're able to in your valve take quality control measurements every 15 seconds, that's great in a municipal setting, especially for security, but also just for peace of mind in an industrial setting as well, as you're able to get real-time feedback that, hey, we're not making any errors and we're going to be in compliance, which I know keeps a lot of folks up at night. Now, this is a big deal, and you can really imagine where a lot of this happened, right? I think it's 40 to 60% of the operating costs in a system like this is really is in the energy for aeration and getting rid of that BOD and getting rid of that nitrogen. Not so different than we run into in a lot of food processing situations. So all of this really is a direct analogy to what you might see in some food plants. So I really do like this example of, hey, here's real live examples of what we're doing today. And it's got all those pieces we talked about. Take an existing system, add in these sensors, gather the information, analyze them, figure out what that means for you, and then move into real time, capture, show, serve it up to the people who can use it, and react. Equals better results. So, again, today, that was a municipal example. How much of this really exists today in the industrial world? Well, sensors are everywhere. I'm sure you guys are aware of this, right? I mean, there's tons of data. Every pump can now be connected. Now, I shouldn't say every pump, but many pumps, flow meters, valves can all be connected to the internet and capture data. There's TSS sensors, pH, BOD, COD, DO, conductivity, and many, many more, of which I'm sure I'm missing. The next kind of level in that, and these exist today, are now they're smart cameras. I would say are not quite at the same evolution as the ones in that first sub-bullet point there. But now we're getting to the point where there are cameras who, based on based on how your flock looks, can send back and make recommendations, or you can tie that visual into actual data points and allow your system to react and change chemical dosing based on what that camera sees and analyzes just visually. So there's a lot of other new technologies. While this exists, it will continue to get better and better, and making it. And so even what you can do with that smart camera, you can probably need maybe two to three sensors in order to achieve the same result. And again, it's another piece of and enabling that visual to your operator on their iPads as they're walking around somewhere else, gives them a lot more information to be able to use and apply their experience without having to sit there in a control panel or walking around the system most of the day. What can you do with the data? We talked a lot about this. You can automate stuff, right? I mean, that's great. You improve the outcomes. You save the labor. Sludge management. This is where I think if you analyze the data and you have an understanding for pump what pump pressure and frequency of running the machines, and you can see how do I get under what conditions do I get the best sludge, meaning the least amount of water, right? And then once you have an understanding for what are the best conditions that produce the best sludge, you can adjust the system upstream to ensure that that's happening on a regular basis. To reduce the amount, make it easier to manage, less maintenance on whatever type of sludge management equipment you're using. The RO is another place where, again, this can be done in SCADA systems, but you can now do this if it's a lot easier through the Internet of Things, if it's an add-on, and again, take in additional other pieces of information from outside of that system. And this is just, a lot where we do this with a lot of customers in recycle and reuse is you can't have an operator there who's constantly changing the settings on the RO system based on the incoming water to maximize the amount of water recovery. But there's no reason you can't put some sensors in there and automate that typically to maximize the amount of water recovery, which I know is a big goal in a lot of food processors, just not only for savings of the water, but just to be good environmental citizens, if you will. Automating chemical dosing and inventory management are another place where the Internet of Things really allows us today to be an easy add-on, and again, saving money on chemical dosing, or just keeping a little bit more working capital freed up on the inventory management side, where you automatically connect it back not only internally but with your suppliers to have them send out your chemicals when they reach a certain predetermined point in their tank levels. Right, so now it just doesn't exist in your SCADA system, but having it in the cloud makes it easier to bring other external people, like your chemical vendor, into the flow to make your operations run more smoothly. Predictive maintenance is another place where, and then this can be done today. Now, every one of our operating environments looks a little different, and our manufacturers' recommendations for life cycle and for maintenance cycles are important, and we should use those as guidelines, but it's going to be a little bit different for all of us. So if you're able to measure that over time and then understand that, hey, my pump is going to work for 800 strokes, not the 1200 strokes that the manufacturer tells me because our environment's a little harsher, again, you can set up the counts and have maintenance notified at around 800 strokes that, hey, it's time to get out there and switch out that pump for maintenance, so we're not suddenly always in run to failure and then having to deal with emergencies and potentially impacting processing downtime. So that's a little bit, I hope that gives us somewhat of a sense for where things are today. It's fairly robust, and again, it looks a lot like what we can do with some of the SCADA systems, but enhanced and more. And it's easier to upgrade existing systems with the Internet of Things technology to be able to do that as an upgrade. Here's another case study for a pork processor, and this is one that we were involved in. And again, this was an existing system, and so we kind of added all this capability on as an add-on through Internet of Things. Again, setting the stage so that we understand why this was important. For the size of this operation, a $300,000 plus annual chemical bill was really high. More important it was a lot of money to be spending. Also, there was just every once in a while they'd still have surcharges and violations, and the city and the municipality was just all over them, and it was a black eye. They have it's an important blue chip consumer brand, and so they didn't want the embarrassment of having their name in the newspaper, right, for having these types of violations. So what they were really looking for were better outcomes and cost savings. The challenges they had, which I'm sure many of you can relate to, is highly variable waste streams, and they couldn't have two people sitting there constantly doing jar testing on the influent to ensure and making the adjustments. So typically the way they handled that was they took the worst case scenario, and then they set the dosing settings on the chemicals at that feed. That's why their bills were so high. They were wildly overdosing. That's also what caused a lot of their unpredictable surcharges as well, frankly, was because sometimes when you overdose, you recreate the problem you were trying to solve in the first place. So that overdosing, while it did protect them in some cases, it didn't protect them as well as they thought. And it wasn't a very good good approach to automation. So the solution was, again, put the sensors in for a while just to measure the influence and the chemical dosaging and understand the impact, as well as other factors that we had, temperature and some other things. Analyze data to determine the optimal chemical dosing under different conditions. Developed that program, programmed everything in, and then automated it. And the outcomes were predictable. Reduced labor by 65%. Now these numbers came from the customer. It seems pretty incredible, but I think they were really, part of that is because, again, they were in trouble with the city. So you start throwing a lot of bodies at that because that's a big problem. So they were able to reduce the labor by 65% by having much more predictable outcomes, and their chemical spent down went down by 40%. Now, one of the other things we did learn through this was that during the cleaning shift, certain cleaning processes were sending chemicals down that were just not going to be treatable in the wastewater treatment system when combined with everything else. And so while violations were greatly reduced, they didn't go away until we worked with them to solve that problem as well, which was just creating a side stream for that small flow during the cleaning shift. So it would also help identify some more issues that we're able to help them solve. So where does this go into the future? More of the same, right? Really the collaborative piece of automation. So think of it now, today it's really about what information can we continue to gather inside of our wastewater treatment system and make better decisions with what we control in the system. As we all know, though, it's also impacted by things that happen upstream in the process. In fact, that's the biggest impact, and that's that variability of the water. Today, you handle that a lot of times through very, very large equalization tanks and trying to create some consistency to the water because you can't predict what's coming in. Well, if you're now plugging in your wastewater treatment decision capabilities to factors, again, outside of your wastewater treatment system, upstream and processing, how will that enable you to make better decisions and potentially be able to get better results that way by working with other parts of the organization, including the municipalities, right? So understanding when they're having events and how might events at the municipality impact how you would operate your wastewater treatment plant. Even if those events weren't caused by you, what could you do to be a better municipal citizen in the operations of your wastewater plant if you knew what was happening downstream when you were discharging? And how might that make change your ability to surcharge and what you could and you couldn't if you were able to have that type of conversation. Process automation, I think we've talked a lot of that. There's a lot of stuff you can do that, and that's just the more data you capture, the more analysis that you get, and the more time you have to live with this, the better decisions you'll be able to make. The predictive maintenance and replacement, again, we kind of talked about that one as well. And the component level advancements, there's only going to be more and more sensors that are coming out and more pieces of equipment that will enable us to capture even more information. I think Gartner predicts that there will be 20 billion connected devices by 2020. I think it's something like 2 billion connected devices today. That's a lot of information. And again, the key to this is, moving on to the next stage, what do we need to think about? Well, look, the technology is going to change, right? Your business goals aren't, and so you're defining what are the things you'd like to improve in your wastewater treatment operations. Better results, lower labor, lower energy costs, lower chemical consumption, whatever it might be. Once you understand what those are, then you have to understand, well, what are the things that might potentially impact that? How do I measure all of those to really understand and create a statistically significant link between those different factors and the results that I'm trying to affect? Once you understand what your business goals are, once you understand what the potential root causes are, you've basically got you've got your plan for Internet of Things. Now what you need to do is constantly be looking for, how do I most cost effectively capture that information and analyze it to drive better long-term results. Some of the things to think about though when you're selecting pieces of equipment to add into your Internet of Things infrastructure, and I won't even get into the companies like C3 IoT or IBM who create that actual platform in this conversation. But some things to think about just at that equipment level is maintenance. I mentioned earlier in this talk about sensor. As sensors get better, you still, especially in wastewater treatment and especially in food processing, those sensors can get fouled pretty quickly. Really understanding what in your particular environment, how often are you going to need to clean those? How effective are those sensors really going to be in today's environment is super important. Running some sort of a trial or seeing them in place at another similar environment, really important to make sure they're going to work for you, or you could end up wasting a lot of money and not getting any results for it. Battery life is another one. Particularly, think of this in the context of municipal, and the advancements are there for this. Think about this in terms of one of the things we didn't talk on the municipal side, where Internet of Things has become a big deal, which is leak identification and maintenance. Right? They've put in many municipalities now. They're starting to put leak sensors scattered throughout their miles and miles and miles of underground pipe infrastructure. And the whole reason they're doing that is so that they can identify leaks and makes maintenance a lot easier when you can pinpoint exactly where it's coming from. And then in the long term, save a lot of money from lack of a lost product, if you will. Same concept, but those batteries need to last for 10, 15 more years without needing to be replaced to make that at all feasible as a strategy. And really, for the most part, that's there. But again, it's one of the things to consider, that depending on where you're going to be putting this, how often, given where I have to put it to get the information that I need, how often am I going to have to access that in order to change a battery or clean it, and is that practical? And last but not least, network security, right? IT is going to have to be a big part of this. Anytime you're talking about connecting pieces of equipment inside of an organization to the internet, you're creating an opportunity for somebody else to get in. And so I'm no network security expert, but I do know that it's one of the things that you need to consider in doing this plan. So I went a little bit, about 10 minutes longer than I had intended to. I apologize, but I do hope that this was helpful and at the right level. I know a lot of you know a lot about this already, potentially more than I do as well. And so thanks for taking the time, and I'd love to see if anybody's got any questions that I might be able to answer. And if this isn't the right forum to do it, you've got my contact information there on the screen. Would love to hear from any and all of you afterwards.
Great. Chris, thank you so much. That was very, very interesting. It's definitely a topic that we hear our members ask about frequently. So for the folks that are on the line, again, pass on the link to anybody in your company that you think would benefit from the information. Chris, we don't have any questions right now, but again, feel free. Chris's information is on the screen to reach out to him anytime. So thank you again, Chris. Really appreciate it. And thank you, everyone, for taking the time today.
Yeah, thank you, everybody. Appreciate the opportunity.
Take care.